AP Chemistry. This is Unit 2 Reactions, Lesson 4. We're going to do more in regard to stoichiometry grams. It's a continuation of Lesson 3. So this is a graphic organizer that kind of lays out what we're trying to accomplish here. So up on the top row it says Our World Grams. We can measure things on a scale in grams. A chemical equation works in terms of numbers of particles. It's trying to match up one CH4 molecule for every 2 molecules of O2. So it's a 2-to-1 relationship. If we talk in terms of moles, these big baskets of molecules, if you have 1 mole of CH4, you have to have 2 moles, 2 times 6.02, 2 times 10 to the 23rd moles, or particles rather, of O2. And again, it's best to just think of those as a relationship, not as a specific number of moles that you have to have. So if you have 4.2 moles of CH4, you're going to need twice that many, 8.4 moles of O2, in order to make that reaction work. So it's always that 2-to-1 relationship. However many moles of CH4, you need twice as many moles of O2. Again, what is a mole? It's counting numbers of particles. It's matching up numbers. But unfortunately, a molecule is too small to see and a mole is too big to count. So we're kind of going to have a problem on both ends there. Fortunately, there's a way we can get to those numbers. And that's by knowing the mass of the substance, knowing the substance first, CH4 or O2 or CO2 or H2O, and then knowing the mass in grams, which we can measure in the lab. If we know those two things, what the substance is, and how many grams we have, we can know exactly how many molecules or how many moles of that substance we have. So fortunately, we have a translator. It's called the molar mass conversion. Molar refers to the moles that the chemical equation works in. Mass refers to grams. We measure mass in grams. So it converts between moles to grams or grams to moles. So each substance or element or substance has its own molar mass. And you get that by simply adding the atomic or molar masses. We're going to think of the periodic table as having molar masses. Those are the numbers down below each element. You add up the molar masses of each element to get the molar mass of a molecule. So carbon has a molar mass of 12.01. Find that on your periodic table. Be sure you know how to get that. For 1 mole of carbon atoms, it's 12.01 grams. Hydrogen has a molar mass of 1.01 grams. You have 4 hydrogen. So 4 times 1.01 is 4.04. You add that to 12.01 for carbon, and for CH4 then you have 16.05 grams for 1 mole of carbon. So remember, a molar mass is always 1 mole of the substance equals some number of grams. For O2, oxygen, 16 is for a single oxygen atom, but oxygen always travels in pairs. That's O2. So 2 times 16 is 32. So 1 mole of oxygen, 6.022 times 10 to the 23rd oxygen molecules, O2 molecules, will equal 32 grams. Will weigh 32 grams. And that's a number we can measure on a scale in a lab. CO2. Carbon, 12.01. Oxygen, we just said, is 32. If you add those two together, you get 44.01 grams for 1 mole of carbon dioxide. And water, finally, oxygen is 16. The 2 hydrogens are 1.01 times 2. That's 2.02. 2.02 plus 16 is 18.02 grams. So it's always, a molar mass is always 1 mole equals some number of grams. You're always setting it to 1 mole. So now, if we know numbers of grams, we can use the molar mass to figure out how many moles we have of each of those substances. Similarly, if we know the number of moles of any of those substances, we can use the molar mass to get back out and tell us how many grams that we have. All right, so that's how you read this graphic organizer. I want you to get used to using it for the next few days, and then eventually I want you to get to where you don't need it. You kind of visualize this pattern or this process that's going on here. Okay, so we're going to go into how many moles of CH4 are required to form 3.2 grams of H2O. All right, very similar to the question we did yesterday, except now it's asking how many moles of CH4. And we're starting with a number that we know, which is 3.2 grams of H2O. Okay, so first, we're going to start with what we know. Grams of H2O. So grams is the top row. That's the our world row. That's grams up there that we can weigh on a scale. And we're in the H2O column, the water column. So you're going to put your number in that box right there, 3.2 grams. Okay, now what are we trying to find? So how many means question mark. It means what are we looking for? What don't we know and that we're trying to find? So how many moles CH4? So that's going to be a question mark. Where is that question mark going to go? Stop the video if you need to and figure out where that question mark will go. Okay, so I'm going to show you. It's going to go right here. It's CH4, so it goes in the CH4 column, and it's moles, so it goes down in chemical world. It goes down in numbers of moles down there in that row down there. So what we need to do is we need to somehow figure out a way to get from 3.2 grams down to that question mark to get our final answer. So how many conversions is that going to take? So let's take a look at that. First, we need to go from 3.2 grams, use our molar mass for water to tell us how many moles of water that we have. Okay, and that's going to put us in that box right there, moles of water. So you're converting from grams of water to moles of water using the molar mass, that translator that does that for us. Once you have moles of water, then you're going to move across to moles of CH4. So we're going to come across here and go from moles of water over to moles of CH4. Now you might ask, could you have started at 3.2 and gone across to grams of CH4? That would have been the top left box up there, and then gone down through the molar mass conversion to get moles of CH4. In other words, just taking a different path. And the answer is no. We don't have any known relationship between grams of water and grams of CH4. We don't know any relationship between grams to grams directly. You have to go into the chemical equation because the only relationship we know is what the chemical equation tells us. That's our recipe. That tells us what the relationship is between moles of CH4, moles of O2, moles of CO2, and moles of H2O. That's the only place where you can move laterally or sideways. So you can only move sideways, left or right, inside the chemical equation. You can't move left or right up there in the grams row. Okay, so trying to kind of get that concept to where that is kind of natural for you. So we go down into the chemical equation, straight down from 3.2 to number of moles of H2O, and then you can go sideways once you're inside because we know we have 2 moles of H2O for every 1 mole of CH4. And that'll get us to our final answer here. So look up above now. You see how we started the equation, and we left a lot of space in between the beginning and the end of the equation. So we're starting with our known, which is 3.2 grams of H2O. On the left and way over on the right, we have some unknown number moles of CH4. That's going to be our final answer. So now we need to fill in that middle space. So our first conversion is to get from 3.2 grams of water down to some number of moles of water. So we're going to use the molar mass. That's our translator to get us into the equation. So first of all, I see that there's 2 conversions. We see that there's 2 conversions. You're going from grams to moles of water, and then from moles of water across to moles of CH4. That's a 2 conversion problem. Okay, so our first equivalency is this. 1 mole of H2O equals 18.02 grams of H2O. That's the molar mass conversion there in the blue box. So from that, you can get 2 conversion factors or ratios. So you should be able to know how to do that by now. So here they are. 18.02 grams of H2O for every 1 mole of H2O, or 1 mole of H2O for every 18.02 grams of H2O. You just put one over the other and then you flip it. So which one of those 2 do we need in the box up above? We're starting off with grams of H2O. We don't have that in our final answer, so that needs to cancel out. So which one do we use? Think about it. Pause the video whenever you need to. We need this one. We need to have grams of H2O on the bottom so it will cancel with grams of H2O over there at the beginning, 3.2 grams of H2O. So all we're doing is canceling units of measure now. So grams of H2O cancels there. And the only thing we have right now is moles of H2O. That means we're down in that bottom right-hand box in the moles row inside the equation right above H2O. Now, you normally don't do intermediate calculations. That is a calculation in the middle of the problem, but I'm going to do it here just to show you how this progression is working, okay? So down in that red box in the bottom right, if you multiply 3.2 times 1 divided by 18.02, you get that number down there, 0.18 moles. So that's how many moles of H2O 3.2 grams is. And we got that using the molar mass. Now we need to move from moles of H2O, that's the 0.18, over across to find our final answer, moles of CH4. So what's the conversion there? And this one is easy, guys. Don't let it fool you. It's simply the coefficient in front of CH4 equals the coefficient in front of H2O. So it's that. 1 mole CH4 equals 2 moles of H2O. Just that simple, just like we did yesterday. So now you can get 2 conversion factors out of that. Be sure you know how to do that. And here they are. 2 moles of H2O for every 1 mole of CH4, or 1 mole of CH4 for every 2 moles of H2O. Which one of those are you going to use? What do you need to cancel, and what do you need to appear in the final answer? That's the question you're asking. The answer is this one right here. So we're going to put this one up here. So we can see that moles of H2O and moles of H2O cancel like that and like that. And the only unit we have left after all those cancellations is moles of CH4, and that's what we want to know. That's our final answer. That's what we're trying to find out, is how many moles of CH4. So that's the last man standing. So now we know we have our units set up properly. So now we're going to go ahead and multiply everything on the top. So here we go. 3.2 times 1 times 1, and then you divide by everything on the bottom. Divided by 18.02 divided by 2. And after you do that on your calculator, you get a final answer of 0.094 moles of CH4. So that's how many moles of CH4 you need to produce 3.2 grams of H2O. And if you want, down in the graphic organizer down below, we're going to write that answer for the question mark. We're going to replace the question mark, and that's our final answer, 0.094 moles of CH4. Here's a bonus question. How many moles of O2 do you need to burn that, or to react with that 0.094 moles of CH4? How many moles of O2 would you need? Well, you need 2 moles of O2 for every 1 mole of CH4. So in order to figure out the number of moles of O2 you would need to cause this reaction, you need to double 2 times 0.094, which would be 1.88. Now that's not really part of this. I'm just trying to get you to start to see these relationships here. So you would need 2 times 0.094 moles of CH4. That would be how many moles of O2 you would need to make this reaction work. Okay, so that's a 2-step problem. A little more involved than the last one. You have to start using your molar mass conversions. Now we're going to go on to the big kahuna here, and that's going to be a 3-step problem. Okay, that's as long as these problems get for right now. So let's go on to the next problem. So here's our question up at top. How many grams of H2O can be formed from 5.02 grams of CH4? So now we're going from grams to grams. So we're going to start with 5.2 grams of CH4. We're in the CH4 column, and we're up in our world. We measured 5.2 grams on a scale, so that goes up above CH4 in the grams row. What are we trying to find out? Where does the question mark go? Grams of H2O. So you go over to the H2O column, and you go up to the grams row, and there's the question mark. So we need to get from that 5.2 over to the question mark. And again, the question may enter your mind, can you go directly from 5.2 grams to that question mark number of grams? And the answer is no. We don't know any relationship between grams of CH4 and grams of H2O. The only relationships we know between CH4 and H2O, or any of the other compounds down there, is inside the chemical equation. It's terms of number of moles, or that relationship between moles. So what we have to do is the following. First is what I just mentioned. You cannot go with that saying with those X's there. You cannot go directly from grams to grams. There's no way to do that. So that's eliminated, that possibility. So we're going to take the 5.2 and we're going to go down using our molar mass conversion. We're going to figure out the number of moles of CH4. We have 5.2 grams. How many moles is that of CH4? Now that we're in the equation, we can move sideways. The only place you can move sideways is inside the equation. So we're going to go from moles of CH4 right there. We're going to go across to get moles of H2O over on the right side, that bottom right box there. Once we have that, we can come back out of the chemical equation using the molar mass of water over there on the right, and we can come out, go up, and get to our question mark. So this is a 3-step problem. It's going to require 3 conversion factors to solve this. Okay, that's the most complicated problem you'll be dealing with in the next week or so. Okay, so let's go ahead and set up our equation. And there you see it up on the top. It's written kind of small because you're going to need 3 conversions here. It's going to get pretty busy, so follow it one step at a time. It'll make sense, and then go back and watch the video again, practice the problems, and it'll start to really make sense. You're going to find this is no harder than it's actually easier than the Usain Bolt problem we did, figuring out how many miles an hour. You only have 2 units of measure that you're working with in these problems, moles and grams. That's it. Okay, you just have to see the pattern between them. So we start with 5.2 grams of CH4, and way over on the right, we're going to end up with some number of grams of H2O. So here we go. Our first conversion is to go from 5.2 grams of CH4 to some number of moles of CH4. We need to get down into the chemical equation. So we're going to use the molar mass. That's our translator. So 3 conversions. You see the 3 boxes right there. So the first one is the molar mass. 1 mole CH4 equals 16.05 grams of CH4. So what are the 2 conversion factors for that? Hopefully that's natural to you by now. You just put one of them over the other, and then you flip it like that. Those are both true statements. 16.05 grams of CH4 for every 1 mole of CH4. That's a true statement. There's 1 mole of CH4 for every 16.05 grams of CH4. That's a true statement. But only one of them is going to help you here. So think about it. Which one are you going to put up there in that box? You need grams of CH4 to cancel. So you need it on the bottom of the conversion factor. So you're going to use that one. So we're going to put that one up here. And now we're going to cancel grams of CH4 with grams of CH4. All right, now again, we're going to do the intermediate conversion. What number does that give you? You normally don't do that. Usually just set up the equation and get to your final answer. But what is 5.2 times 1 divided by 16.05? That's going to be, down there you see in the bottom left-hand corner, 0.29 moles. So at this point, that's where we are in this path. We have 0.29 moles of CH4. Now we need to get from moles of CH4 to moles of H2O. And we do that exactly the same way we did in the last problem. Except we were going in the other direction actually, but it's the same relationship. So here it is. There's 1 mole of CH4 for every 2 moles of H2O. It's just simply whatever the coefficient is in front of each of those compounds, that's what it is. So this is a very easy equivalency to come up with. Now you need to come up with the 2 conversion factors. So what are they? One over the other, or flip it. Okay? So now, which of those 2 are you going to put in that second box there? Think about it. You have moles of CH4 up in the first conversion. You need that to go away because it's not in your final answer. So we're going to put in the one that gets rid of moles of CH4, and that's this one right here. So we're going to put that in there and make moles of CH4 cancel with moles of CH4, and that's our second conversion. Now we're going to go ahead and run the numbers on that and put it in the box way down on the bottom right. 5.2 times 1 divided by 2, let me start that again. 5.2 times 1 times 2, everything on the top multiplied, divided by everything on the bottom, divided by 16.05, divided by 1. And that would give us a number of 0.58 moles of H2O. Notice that the number of moles of H2O is twice the number of moles of CH4. It's a 2-to-1 relationship, okay? 0.58 is twice 0.29. Okay, so now we're ready to come out and get our final answer. So we need to use the molar mass for water over there. Just follow the arrows. So the molar mass is 1 mole of H2O equals 18.02 grams of H2O. So create your two conversion ratios or two conversion factors, either one. And there they are, one over the other, or flip it. Okay, so which one of those goes in that last box? Well, we have moles of H2O in the second conversion factor. We need that to go away because it's not in our final answer. And we do need grams of H2O to show up on the top because that is in our final answer, and this is our last conversion. So that means we're going to use this one. So we put that in. Moles of H2O cancels with moles of H2O. And the last man standing, the only units left after you've done all your cancellations, is grams of H2O. And that's what's in your final answer. So now you're ready to just do your math. 5.2 times 1 times 2 times 18.02 divided by 16.05 divided by 1 divided by 1. Of course, you know the multiplies and divides by 1. You don't really have to do them, but I'm just trying to be thorough and show you what you're doing. You're multiplying everything on the top, dividing by everything on the bottom. And when you do all that, you get 2.9 grams of H2O. All right? So we can put that in our question mark box down below if we so desire. We'll go ahead and do that. And that's our final answer. So again, to move sideways, to move between compounds in the equation, the only relationship we know is that recipe called a chemical equation. We have to be down in the chemical equation to move between substances. We can't do that up in our world of grams. There's no way to move sideways between grams. You have to go into the chemical equation, get into numbers of moles, move from side to side between numbers of moles, and then come back out to numbers of grams. And that is all for this. That's a lot. Okay, you're going to practice a lot of these over the next few weeks. You need to become really good at these. And grams to moles conversions are very important. This gram stoichiometry. That's why I call this gram stoichiometry. So now you really have a feel of what stoichiometry is. It's the math that's involved in using a chemical equation, of getting into a chemical equation, figuring out what you want to figure out, and coming back out. Okay, that's what stoichiometry is. All right, so we're going to practice a lot of these. Especially over the weekend, and that will take care of that. So have a good weekend, or have a good day, and we'll see you on the next lesson.